Can you imagine a future where humans are not just earthbound but are exploring the far reaches of the cosmos? Picture this: a time when the idea of conquering space was nothing more than a figment of science fiction. But, as we know, curiosity is a compelling force. It drove our ancestors to look up at the night sky and wonder what's out there. Fueled by this curiosity, the development of space exploration began. Early pioneers, armed with nothing more than rudimentary telescopes, began to map out the celestial bodies, providing us with our first glimpse into the vast expanse beyond our planet. But it was the invention of the rocket that truly ignited the era of space exploration. These remarkable machines, defying gravity, propelled us into the unknown, paving the way for the future of space exploration. As we journeyed into the unknown, our thirst for knowledge led to the development of more sophisticated technologies. The launch of the first satellite, Sputnik, marked a new era in space exploration. This era was defined by the use of satellites and probes, the silent observers of the cosmos. These technologies serve as our eyes and ears in the vast expanse of space, tirelessly gathering information about our celestial neighbors and the far reaches of the universe. They help us study celestial bodies from the smallest asteroid to the largest galaxy, revealing secrets about their composition, climate, and potential for life. They also keep a constant watch on Earth's atmosphere, providing key data about climate change, weather patterns, and natural disasters. Beyond this, satellites and probes have revolutionized communication. They've shrunk the world, enabling us to send signals across continents in the blink of an eye. In essence, these technologies have become our lifeline to the universe, transforming our understanding of it and our place within it. These technologies opened up new possibilities, but the best was yet to come. A giant leap for mankind, the Apollo moon landing showcased the pinnacle of human achievement. This event marked the dawn of the Age of Manned Spaceflight, a period that saw humans leave the confines of our planet for the first time. The technology that fueled this era was nothing short of revolutionary. Take the Saturn V rocket, for instance. Standing as tall as a 36-story building, it was the most powerful machine ever built by humans. It was designed to carry astronauts beyond the Earth's atmosphere, all the way to the moon. Then, there was the lunar module, a spacecraft specifically engineered for lunar landing. It was a marvel of engineering, capable of safely descending to the lunar surface and then launching back into space for the return journey to Earth. These technological advancements were not just about reaching the moon, they were about pushing the boundaries of human capability and understanding. This monumental achievement was just a stepping stone to greater feats in space exploration. The vastness of space calls for more efficient ways of traversing it, and thus, the advent of advanced propulsion systems. These innovative techniques are revolutionizing our approach to space exploration, offering faster and more efficient travel. Firstly, let's talk about ion propulsion. This isn't the stuff of science fiction but a reality. Ion propulsion works by electrically charging or ionizing a gas and then expelling the ions. The result? A thrust that can propel spacecraft at incredibly high speeds. While the thrust produced may be low, ion propulsion systems can operate for a long time, gradually increasing a spacecraft's speed over months or even years. This makes them perfect for long-duration missions, such as those to distant planets or asteroids. Next on the list is nuclear propulsion. This method uses nuclear reactions to generate thrust, harnessing the immense energy locked within atomic nuclei. There are two main types: nuclear thermal and nuclear electric. Nuclear thermal propulsion involves heating a propellant by passing it through a nuclear reactor, while nuclear electric propulsion uses a nuclear reactor to generate electricity, which then powers an electric propulsion system. Both of these methods could potentially offer greater efficiency and speed than traditional chemical rockets. Lastly, we delve into the realm of antimatter propulsion. Antimatter is the mirror image of normal matter, and when the two come into contact, they annihilate each other, releasing a huge amount of energy. If we can harness this energy, we could propel spacecraft to near light speed. While we're still a long way off from developing a practical antimatter engine, the potential benefits are enormous. These advanced propulsion systems could be game changers in our quest to explore the cosmos. By increasing speed and efficiency, we can reach farther into space in less time than ever before. The implications are vast, from making manned missions to Mars more feasible, to potentially enabling us to reach other star systems. These promising technologies could drastically cut travel times, making interstellar travel a reality. As we continue to push the boundaries of what's possible, who knows what new horizons we may uncover in the depths of space. In the quest to understand the universe, we are turning to our most advanced technology, artificial intelligence. Artificial intelligence, or AI, is not just a concept from science fiction. It's a real-world tool that's helping us to explore the cosmos like never before. AI is a game changer in space research, and it's being utilized in several key areas. One of these is data analysis. Astronomers and scientists are inundated with vast amounts of data from telescopes and satellites that monitor the universe. This is where AI steps in. It can sift through this data at an incredible speed, identifying patterns and anomalies that might otherwise be missed. It can detect a distant galaxy, identify a new planet, or even spot signals from alien civilizations. Next, we have autonomous navigation. Space is vast and unpredictable. To traverse this unknown terrain, spacecraft need to be able to make split-second decisions. AI-powered systems can do this, navigating around obstacles such as asteroids and making course corrections on the fly. This not only increases the safety of the mission, but also frees up human resources for other critical tasks. Finally, AI is an invaluable tool for problem-solving in space missions. When things go wrong in space, there's often little time to react and no room for error. AI can analyze the situation, consider all possible solutions, and choose the best course of action in a fraction of the time it would take a human. This could be the difference between mission success and failure. The potential of AI in revolutionizing space exploration is immense. It's not just about making our current methods more efficient, it's about opening up new possibilities. With AI, we could carry out more complex missions, explore farther into the universe, and perhaps answer some of our biggest questions about the cosmos. As we stand on the brink of a new era, the potential of these technologies is only limited by our imagination.